Hi, my name is Brendan. I'm part of the Clean Snowmobile Club at Montana State University, and I'm a senior studying mechanical engineering.
My name's Thomas. I'm also a senior studying mechanical engineering.
So we're a club that participates in the SAE-sponsored Clean Snowmobile Challenge to make snowmobiles cleaner, quieter, and more efficient. Thomas is going to tell you a bit more about the club and what we'll be doing today.
Yep. So as Brendan said, in the Clean Snowmobile Club, we try to design components and modify existing ones inside a snowmobile to make the entire snowmobile cleaner, quieter, and more efficient. So far, we have implemented catalytic converters, which help reduce pollution from the exhaust. We've also changed how the engine runs to maximize efficiency, and we've designed our own exhaust system and muffler, even more efficient and even quieter. Every year for competition, we get to go to Michigan to see how our snowmobile stacks up against other teams from other schools.
So today we're going to show you how engines, specifically combustion engines, capture the energy from combustion and translate it from linear to rotary motion. Now a quick safety note before we get started. We're going to be using scissors and push pins to create our models, so please take care to not poke or cut yourself. Please ask a parent or adult to help with the cutting and poking.
Okay, so everything we need today is right here.
First things first, we're going to mark everything that we'll be cutting out today. First, we need a circle, about 4 inches in diameter. Now, we're going to be using a water bottle to trace our circle, but any object that's circular and about 4 inches in diameter will do. Next, we'll need two long rectangles, roughly 3 inches by 1/2 inch. And one more rectangle, 5 inches by 1/2 inch. Finally, we'll need a square 3/4 inch by 3/4 inch. Now notice that all the shapes we've drawn have been on 1/2 of the cardboard. It doesn't have to be exactly these dimensions, but you want to make sure before you start cutting, you'll have roughly 7 inches by 4 inches of cardboard that we can use as a back plate to mount all of these shapes onto.
Now we can start putting it all together. Here's a peek at how everything's going to go together in the end. So that's basically what the form will be in the end, and I'm going to walk you through the steps on how to. So what we're going to do first is we're going to set these two rectangles down with the square in between them acting as a spacer, and we want to attach the two rectangles to the bottom plate of cardboard without attaching the square. I'm going to use tape for that. Feel free to use glue. Now we want to make sure that these two rectangles have enough space for the square to slide between them without getting stuck on the sides or without letting it move back and forth too much. This is a good enough amount of space. Alright, so now we're going to pin this circle to the cardboard base right about here. And we want the pin going through the center of the circle so it can rotate without it being too wobbly like this. Like I said, the center of the circle, and ideally the center of the circle is in line with the center of this channel that we created previously. So I'm going to do that, this little poker guy.
Put it down close to the center.
Poking it all the way through. I'm going to line that up. Poke through my back piece of cardboard. Now I'm going to take a pin, come through the back of this piece of cardboard. It's a little hard to see this step, so be very careful about where your fingers are and where the sharp end of the pin is. Alright, so we have this step set up, but I'm not locking this cotter pin in place by bending its legs down just yet. First, we need to set up our connecting rod. So, if you guys remember, this is basically what the final design looked like. And what we want to do is we want a pinned connection right here and a pinned connection right here connecting the square and this rectangle and this rectangle and the circle. So I'm going to mark really carefully by just poking through as I've said before, none of these measurements are super high tolerance, so it should all work out in the end. Alright, so it's time to put it all together. Now, we're going to have to pull our circle for this step, and I'm going to take a cotter pin and poke it through the back side of the circle here. If you guys are using thumbtacks, you're not going to have to do as many steps with your pins. But we want to make sure that however we're doing this, we have a flat surface for the circle to ride along. So I've bent the cotter pin a little bit like that so it can lay flat along the cardboard and spin without getting in too much trouble. Alright, then I'm going to poke the connecting rod through. And then we're finally going to attach the square. I'm going to follow the same process that I did previously, just so, again, we have a flat surface to drag along the cardboard when this is in motion. So these two pieces are in. Now I'm going to put the circle back into this pinhole. Again, be really careful with where your fingers are and where these pins are. And now I'm going to bend these cotter pins down. A flat thumbtack would work really well right here, but I don't have any of those, so we're using cotter pins. And voila, we have created the shape that we discussed earlier. Question is, what have we created?
So let's talk a little bit about what we've created here. This is a very rudimentary model of an engine. Each of our parts is, this top part represents the cylinder of the engine, with these two pieces being the cylinder wall. They keep this little square part, which is representing a piston, in one smooth line. That is to say, if we exert a force on the top, it can only move downwards. If we exert a force on the bottom, it can only move upwards, thanks to these two walls. Down here, we have our crankshaft, and here we have our connecting rod. Its purpose is to connect the motion of the piston to the motion of the connecting rod. So we have these two arrows here. What are they for? Well, the overall goal of this system is to get motion coming upwards and downwards in the piston and turn it into motion, rotary motion, of the crankshaft spinning. The idea there is we can then use the spinning of the crankshaft to turn a wheel, or a track in our case, which is substantially more useful for automotive applications. So how do we get this linear motion in our engine in the first place? Well, we inject gasoline or some other fuel into the combustion chamber, which is the area above the piston between the two walls. And then, as the piston comes up, the explosion will drive the piston violently downwards with a great amount of energy. And when we get to the bottom, it'll start coming back up. Then we inject more fuel in this part of the cycle. As the piston is coming up, it becomes very compressed. We have a ton of pressure right here, and eventually there's so much pressure and energy built up here that we reach something called the flash point of the fuel. And once again, it's going to go ahead and explode and drive this downwards. Now, as you can see, this up and downwards motion is not particularly useful for turning a wheel, but the specific layout of our connecting rod and the piston allow us to turn a wheel smoothly and capture that energy in a more useful manner. So you may have heard people reference the number of cylinders in an engine before. It's a convenient way to increase the overall volume of the engine, thereby allowing us to create more power inside of the engine. Now Thomas is going to help me demonstrate this concept. We're going to use this model to create a very simple two-cylinder engine. So each of these represents one of the cylinders. Now, as you can see, this is the one we made together. This one we had before, we've been using for demonstrative purposes. Now, this pencil would go ahead and connect right here these two the two wheels, which are both part of the crankshaft. And so when this piston is at the top and it's driven downwards, it will cause the other piston to move upwards by rotating the shaft that we're representing with the pencil. Now, this piston is at the bottom, but the piston in the other cylinder is at the top. So we get an explosion there, which allows this bottom piston to come back up. And by doing so, we're able to get consistent combustion. And these two cylinders, or these two pistons, will always be at opposite locations in the cylinder. One will be at the top, when the other is at the bottom, and so on and so forth. But they will always work together to keep steady motion going and to keep all parts of this rod spinning in the same direction so that we can eventually drive a wheel or a track or anything else that we want to power by spinning around.
So we've discussed how the linear motion of a piston can turn a crankshaft. Let's look at what goes on inside a real engine and see how that compares to the model we made.
Whoa. Real quick, I just want to point out, we have a lot of fun working on engines, and we have a lot of experience with this specific one. There's a lot of potential for things to go wrong, working with a lot of moving parts that are very hot. So never try to touch or work with an engine without adult supervision.
So in this demo, right now, we just have Brendan pulling on the crankshaft to move these pistons. In reality, there would be explosions happening thousands of times per minute in here, which would be pushing the cylinders down and causing that crankshaft to rotate. Then, when the crankshaft rotates, it spins this belt right here, which in turn is connected to another pulley, and then it goes to our track, allowing our snowmobile to move forward.
Thanks for taking the time to hang out with us and complete our engine demonstration. We hope you learned a thing or two and had as much fun as we did. We're the Clean Snowmobile Club at Montana State University. Go Cats!